critical angle and total internal reflection of a light. Now we know that reflection of light, you can imagine this is the surface of water or any liquid. So inside the surface of water, if there is any source of light is, when it goes outside, okay, from this water outside, now from this surface of water it will bend. Okay, outside is air and inside is water. Now this phenomena we already know that this is called refraction. Now when you imagine from this surface a straight line which is called normal NO. Okay, now the angle between this normal and incident ray which is called I, angle of incident, and similarly outside angle between this normal and refracted light outside, this is called R, angle of refraction. Okay, now if you increase the angle of this ray of incidence, this, if you increase this angle, okay, then this angle also will be increases. Or if you increase the angle of incidence, then angle of refraction also increases. Now when you increase and increase, finally this angle makes 90 degree. Or suppose there is, or when you increase the angle of this incidence, okay, or if you change the source of light on this point, okay, now this angle is increased. Now angle of incidence is increased, then angle of refraction also increases and it goes in this surface or actually on the surface, or this angle will be 90 degree. Okay, then the value of angle or angle of incidence will be, or it is called C, or this is called critical angle. Okay, this is called critical angle. When the refraction of light becomes 90 degree with respect to normal, then angle of incidence called critical angle. Now we'll get three cases. If angle of incidence becomes less than, okay, less than this angle of incidence, then this ray will be outside in the air, or which is less than 90 degree, and also few parts will be reflected, okay, inside. Clear? Or if you see here in a single diagram, you will get this. If angle of incidence is less than critical angle, okay, critical angle, less than critical angle, then ray of light goes outside, refracted ray, and little part will be reflected inside. Reflected inside. So we'll get two parts. Okay, if the angle of incidence will be less than critical angle, then light goes in two directions, two parts. One will be outside, refracted, and part will be reflected inside the same medium. Okay, this was case 1. Clear? And in case 2, when angle of incidence becomes actually equal to the critical angle, then this refracted ray goes actually on the straight line from the surface, or 90 degree. Okay, and few parts will be inside the water, again reflected ray inside. And finally, third point is when angle of incidence becomes more than critical angle, then all the rays goes inside. Okay, and this refracted ray also goes inside, or only there will be reflection. Okay, if the angle of incidence will be more than the critical angle, then all the ray will be reflected back towards the same medium, or it was coming from water, again it will reflect inside the same water or towards the same medium, which is called total internal reflection. This was the three cases of critical angle or total internal reflection.